of the day will be examples. This is meant to be our catch-up day, so it's perfectly fine that we're wrapping up old slides today. I'll have the lecture channel open in Discord once my phone loads, as always. So let's do it. How do I feel like I'm forgetting everything I know? The down arrow. No, I hit spacebar. That's all right. There we go. So I'll redo a couple slides. I know we got into array lists just a little bit, but I rushed it. I just said a couple things, and let's just take it from the top to refresh where we were. So array list is going to be our typical sequential data structure that's indexed starting at 0. You've seen this data structure in whatever language you're coming from. We have these in every language. We love this data structure. Just index from 0 up to the length -1 and access values at those indices, insert values at those indices. This is our list in Python, our array in JavaScript, our vector in C++, kind of vanilla arrays in C, I guess, but the parallels break down a little bit in that one. And the order does matter in these. So if you insert the values in a particular order, they will stay in that order, which is unlike the hash maps that we'll talk about later, our key value stores, where order doesn't matter. Order does matter with these things. It's the big difference between the two data structures. This is our first class that we have to import. So that package and the name of the class, that does become important when we're importing. Well, it's always important, but it's important when we're importing as well. We need to know how to get access to other code in Java. So Java comes with a lot of built-in classes, and before we can use those classes, we have to import them. So this ArrayList class that we want to use lives in the java.util package. So if we look at Java's library's source code, there's a directory called Java with a subdirectory called util that has a file named ArrayList.java. We know that because Java enforces that directory structure and that naming convention. So we're going to import ArrayList, and then we're allowed to use it. Well, not there. Then we're allowed to use it throughout our code. We can use that ArrayList class. The classes we've used so far, we didn't have to do this because there are certain classes that are just auto-imported in Java. System, string, all our primitives, anything that starts with a lowercase letter, and there's always one that I forget, but I don't see it on screen right now. Maybe I don't have it in this example. But all those are auto-imported. They're so fundamental to programming that Java developers said, you know what, we're going to import those ones for you. You ain't got to worry about it. But anything else, which today is going to be ArrayList and HashMap, anything else we want to use, we do need to explicitly import. But luckily, IntelliJ really has us covered. Modern development tools, IDEs namely, in this context, really make this pretty easy. It's hard to forget your imports because as soon as you type out ArrayList and start using it, IntelliJ usually just automatically adds the import for you. So it's not as big of a deal as it used to be. We used to actually have to remember that. But now that's done for us automatically, and we can focus our brain power on bigger and better things these days. Like constructors. So this we do have to worry about. We're using the ArrayList class, and what we're actually doing is creating an ArrayList object or an instance of an ArrayList. In Python, this was easy. We just had, we'd say my list equals, and then 2 square brackets. And then that would just create our list for us. We'd have an empty list, and then we could start working with it. ArrayList in Java, we have to do a little bit more work. For better or worse, we have to do this, exactly this. So we're going to use the keyword new, which is going to say, give me a new object. And for now, object, that just means we want an actual ArrayList, not working with the ArrayList class. We want an actual hash map, not working with the hash map class. We have a long conversation about that in week 4. For now, it's just creating an instance of an ArrayList, creating an ArrayList. So new is going to do that. It's going to say, give me an instance of this class called an object. We have these angle brackets, which is going to specify the type parameter on the right-hand side of the equal when we're creating an ArrayList. These are usually empty. I'll talk about it more when I get to this one. We can put something here, but we don't have to, so we usually don't. Why do more typing than we have to? And then an empty parentheses. This is actually calling a special method called a constructor. The important thing right now is that it is a method call, so it does need an argument list. We're not giving it any arguments, but we still need the argument list even though it's empty. So new is calling a special method called a constructor, and the method's name matches the class name. All that is going to give us a new array list. It's going to create a new array list, which when we get to the memory diagram, we'll see this, but it's going to go on the heap. And then what it's going to return, what new and the constructor call returns, is going to be a reference to that object on the heap. I'll leave that conversation at that for now, but when we get to the memory diagram, I got a lot more to say about it. And then when we create a variable that's going to store an array list, we still need the type. This is Java, we're strongly typed. We need a type for every variable that we create, which the type is going to be array list, but it's not just array list. Java extends this idea of strong typing, that everything needs a type, all the way to the type that your data structures are going to store. So you don't just create a variable of type array list, you create a variable of type array list of some other type. So this is going to be an array list of integers, which means this array list can only ever store integers, ever. Can't put anything else in this array list except integers. If we try to put a string into this array list, we're going to get an error. It's not going to work. That's something we took for granted in Python. We could just mix our types. Now we can't anymore. So this is an array list of integer. And notice that I'm using integer with a capital I and not int with a lowercase I. Here's where I can finally start this conversation. I've mentioned the word primitive a few times throughout the semester. I kind of slipped. I didn't mean to mention it earlier until right now. But the difference between a primitive and a class type. A primitive starts with a lowercase letter. Any type that starts with a lowercase letter, those are our primitive types. This is int, double Boolean, are the ones that we've seen, the ones that we'll use throughout the semester. Well, those primitive types can't be the type of an array list. You cannot have an array list of int with a lowercase I. Java won't let you. It'll say there's something wrong with your code, and it will break. It won't run at all. Can't do it. So we do need actual class types in the, that's the one I meant to point to, integer. Integer is auto-imported as well. We do need an actual class type defined by a whole Java class that defines the type and create instances of that type, just like we did with array list. We have to do that same thing, well, similar thing, which I'll explain on this slide. So we need to use our class equivalent types for our primitives. For integer, for int, this is capital I integer. For double, it's capital D double. For Boolean, it's capital B Boolean. We need to use these types as our type parameters for our data structures. Yeah.
So every class, I just want to clarify, every class that we create or Java uses starts with a capital letter.
Yes. So I believe you can create classes that start with lowercase letters, but you should not, if that even is allowed. I forget if it's allowed or not, but you should not if it is allowed. Just because of the naming convention. Yeah. If you started with a capital letter, that's your way of saying this is a primitive type, but it's not a primitive type if you're creating it. I should double check that to see. It shouldn't even be allowed, but I think it is allowed, but you should not do it. And Java internally never does that. So we have to use these class types that start with the uppercase letters. So we create an array list of integer. And Java is really good about converting between the two, the primitive types and its equivalent class type. And it'll switch between them using something called auto-boxing, which is something we don't have to worry about because Java does it for us. It's really good. It's really nice. So if I have right here where I have an int, and I'm trying to add it into an array list of integer, Java's just going to convert that int into an integer. When I have right here, I have an int, and I'm adding a capital I integer to it, Java's going to convert that capital I integer, the class type, into the primitive type. It's just going to work automatically. We can use these interchangeably, bless you, in most cases. There's one case where it will mess us up, and that's when it's your return type. Specifically when you're submitting to AutoLab and you have the wrong return type. And I see students, I have no idea why, it baffles me, but they do this every semester. Don't be the person who does this. In the homework assignments and in my lecture examples and everything, but where it will actually matter to you, I will always use the primitive types unless we need the class equivalent. So whenever you're returning an integer value, it's of type int. It is not type capital I integer. It's always the primitive type that I'll use in the homework assignments. It'll say write in the homework document, write a method that returns an int. I will never say write a method that returns an integer with a capital I. I'll never say that. It's always int. Some of you will return integer and you'll get an error and you'll say, what does this error mean? And the AutoLab error message even says like expected int got integer. Like I print out the error message for you in AutoLab too. And there will be Piazza posts. I have no idea why. If you're reading the homework doc and it says int, you hold shift, type I, and type out integer. Don't know why. Some of you will do it. Tell me why. I have a suspicion why people do that. It's because they didn't type their own code, but nobody will admit that to my face. Yep.
So are the primitives and their class equivalents like stored the same in memory, or are they stored differently?
Ooh, that's a good question. I believe they are stored differently. I believe the class equivalents are on the heap, but I'm not 100% sure on that, so I wouldn't rely on that answer. It's something I haven't looked into that in a long time. I knew at one point in time, but I forgot. But I believe they should be stored on the heap instead of the stack like primitives are. So I'll use the primitive types. The only time we need to use the class equivalents is as type parameters in our data structures. That's the only time I'll ever use it. I won't use it as inputs or return values as any of those types. In this class, anyway. Actually, I do that anyway, but in this class for sure. All right, and then finally using an array list. Once we create one, we're going to use add to add a value to the array list, and it's going to add it at the next available index. So when this is an empty array list, it's going to add that at index 1. If it's an array list with one value in it, index 0. If it has one element in it, it'll add that at index 1. And then 2 elements in it, it'll add it at index 2, so on and so forth. And then .get, you cannot use this bracket notation. You can't say rn and then bracket x bracket. You can't access values at a specific index. That is the common notation in a lot of languages. You cannot do that in Java. Can't do it. Not allowed. That syntax just doesn't exist. We have to call a method. We're going to use our dot operator to call the get method. That's how we do things in Java, is using that operator. Dot get, and then the index gets the value at a specific index. I didn't quite get to this slide on Wednesday, and it was the lecture question. So if you did get that one wrong, you'll notice that you do have credit for that lecture question. It wasn't quite fair, so you have credit for Wednesday's lecture question no matter what you answered. But this was the big point I wanted to get with that one. You can't use that notation that we used in Python. You have to use the .get method to access your values. You have to use .add to add values, or one of the other methods available in the class. Now let's see it in memory. Okay, so let's go through this. Everything starts off the same. We have the stack, we have the heap, but oh my goodness, right from the very first line, we're going to have a lot of different stuff going on, which this will be important throughout the whole rest of the semester. We're going to follow this structure of calling a constructor and creating an object on the heap. We're going to do this so many times. So this is the very first time. If it doesn't all make sense today, don't worry. You're going to see this like 100 more times throughout the semester. So let's do it. We're going to create our first object on the heap. All right. So our array list is going to go on the heap. I already said that a few times. But when we're creating an array list, this is calling a special method called the constructor. If it's calling a special method called the you know what? I actually don't do that right now. We don't do that till week 4. Sorry. We don't put that constructor on the stack. So I'll foreshadow a little bit, but we don't do it for array lists. Since it is a method call, starting week 4, we're going to see that those go on the stack. They do create stack frames. We have a whole bunch of stuff going on. I do like to keep it simpler for the first time we see it, but week 4 we'll get into all the details. But we are going to create this array list on the heap. The constructor will create an array list, and we're going to represent this with kind of a mini stack frame, for the notation at least, where we have 2 columns for the names and values of all the variables kind of in the array list. For an array list, it's a little bit different. It's going to be the indices and then the values at each indice, and that's how we'll represent our array list on the heap. And whenever we put an object on the heap, we're going to give it a reference number. What this reference number represents is its location in memory. So when we create an object on the heap, remember, we're going to the operating system and saying, hey, I really want an array list. I want a new array list. Can you give me some space on the heap in memory? The operating system's going to take however much space we ask for, which is however much we need for our array list, and allocate that memory for our program, and then tell us at what memory address that memory is that was allocated to us. And that memory address, remember, memory is like one giant array. This is the index for the first byte of the subsection of that array that was allocated for this array list. For our memory diagrams, since we don't have an operating system to ask for space and to get an actual memory address, we're going to make up numbers. When I made this slide, I was feeling the number 200. So we do OX200. The OX means that the number is a hexadecimal number. If that doesn't mean much to you, just remember to always put your OX in. If you forget your OX, I don't actually care that much. But I'll put my OX in the slides because it technically is a hex address to access a location in memory. So OX200 is going to be the memory address that I made up for this example of the location of this array list in memory. Yep. No, it should be there, but if you leave it out, I don't care. Like, that's never going to be a pass-fail decision maker. Like, if this was a percentage-based course, maybe you get like a 98 for forgetting that or something. But since it's pass-fail, that's not going to be the deal breaker. And then what's stored on the stack, or what's stored in any variable that, what we would think of as storing an array list, or storing a data structure, storing anything that's on the heap, what's actually stored in that variable is just the reference, only the reference. So what's stored in R1 is not an array list. It's a variable type array list. It's just store an array list, right? No. It stores a reference to an array list. So this reference, it's the location in memory where that array list lives on the heap. So effectively what R1 gets is a map. It's a map of memory that says, hey, here's the directions of where you can go to find an array list. And it'll be the array list that happens to be at memory address OX200. It's the only thing that's stored in that variable. And then we're ready to use this array list. So we're going to enter our loop. It's a code block. X is declared within the code block, so we have our dashed box. X equals 0. We're going to hit this line, R1 dot. I don't think I explained that in my slides yet. I saved that whole conversation for week 4, but I want to talk about it here too. We're going to hit this dot operator, R1 dot, which you've used this a lot in 115. Whatever language you're coming from, transferring in or whatever, you've used the dot operator a lot in any language you've used. But what it actually means, let's talk about that, is R1 is a reference. It's not an array list. It's just directions of where in the heap you can find an array list. The dot operator says follow those directions. So whenever we hit the dot operator, what that means is, hey, I know you store a reference. I don't care about that reference at all. I care about the object to which that reference refers. Take me to that object. So R1 dot means R1 dot, follow the reference. That takes us to this location in the heap. And then at that location, we're going to call the add method. So the add method is being called on this array list. And then we're going to add 10, 10 minus 0, so 10 to the array list. When we add to an array list, it's added to the next available location, which is index 0. So we add that to the array list on the heap. At index 0, we're storing the value 10. Does the reference number have to be 3 digits? No. I use 3 digits for my slides. I don't know why. I think that's just because the first time I saw memory diagrams, it was shown to me with 3 digits. But actually, I do have a better answer for that. When you go into IntelliJ and view these references, usually they're 3 digits. So that stuck with me too. I think it's a combination of those two things. But no, some students like to use OX1, OX2, OX3 on quizzes. Perfectly fine. Yep.
Is that why when you don't specify arrays.toString, you try to print an array, it gives you a weird number like that?
Yes. So that number is, and I blur the lines a little bit. It's not exactly the reference, but it's something related to the reference. You get that long hex value. That's the reference. It'll be type and then at some randomish value. It's internal to the JVM. It has all kinds of weird things that it obfuscates, but it's related to that. Yep.
Is that useful at all?
No. No. I have never found a use for it. I've never heard of anybody who found a use for it. No, it's not. Even the toString, the documentation in Java says you really should override this toString method because it's pretty useless. I don't know why it prints that by default, but it does. All right, and I won't go through the whole loop. You know loops. I showed you a couple of them. I don't think we have to really belabor that. I'm not going to say, again, X. Well, I'm not even going to say it. And then we're going to print out the array list. When you print out an array list, for what it's worth, you get this notation. This is another thing where if you don't get the exact notation on a quiz, I really don't care. But for what it's worth, this is the notation you'll get. You'll get the square brackets and then comma-separated values. So we're printing out at index 0 is 10, index 1 is 9, index 2 is 8, index 3 is 7. So we'll print out this array list, index 0, 1, 2, 3. Oh, I realize I still have my summer mouse. I got to increase my mouse size. Go back to that. Oh, I don't like that outside of lecture, but I got to make my mouse bigger so you can see what I'm pointing to. I point with my mouse a lot, so I'll make it bigger probably after this lecture. So we get to our first assignment by reference. This is the reason why references matter. This is why I'm going to wave my arms a whole bunch and talk about these references. R1 only stores a reference to an array list. Like, who actually cares? This is going to be why we care. If we have an assignment from one variable to another, and those variables store references and not values, whereas like int out equals 0, this primitive value is just going to store the actual value of that int. So when we have the opposite, but when we have something here where we have R2, which is going to be a variable of type array list of integer, which is going to be a variable meant to store a reference to an array list on the heap, and we assign R1 to R2, we just get the reference. This is assigned by reference. So R1, whenever we have an assignment like this, R1, we look to whatever's sitting right next to it on the stack, and that's what's assigned. We don't follow the reference. We don't do anything. R1 just stores this reference. R2 equals R1 means take this thing that R1 is storing, which is the only thing R1 stores, and put it into R2. So what we have in effect is two variables that refer to one object. There's only one object in the heap, and we have two variables that both refer to that same object. This is a key difference. Without understanding this, you can get some really strange behavior in your programs that'll drive you nuts. We need to understand references. And this will be what the first quiz is mostly about, is classes, constructors, and references when we get to all that stuff. So that's assigned by reference. Yes, for all of those of you who know, I have to give my asterisk here. It is technically assigned by value, but the value being assigned is a reference. I don't feel like saying that every single time. I'm sorry, but I'm going to incorrectly say it's assigned by reference. It's a very technical difference, something you'll talk about in 220. When you have C, when there is a difference between those, Java only has assigned by value, but the values happen to be references if the values are references, I guess. C actually has legit assigned by reference, which is a whole different thing. Very subtle difference, but an important difference. But it's only important in 220 because Java doesn't actually have assigned by reference. So I'm just going to steal that term. So it's just less syllables to have to say assigned by value, but the value is a reference. I'm just going to say assigned by reference. But technically it's not. So anybody who wants to call me out on that, I'm calling myself out. Yes, I'm being a little incorrect there. So when I print R2, I'm going to get the same array list as R1. And that's not too interesting yet. Oh, let me hold off on that one a little bit. It's not too interesting yet because this line right here, you'll really never do this. Like, there's no reason to have two variables in the same stack frame that refer to the same object on the heap. Now, there's no reason for this line to ever exist except for a lecture example. But where this is important is when that assignment spans multiple stack frames. So when we call a method that takes a type that is stored by reference, that's when things get interesting, because this is something we'll do in programming all the time. We'll write a method that takes a reference to an object. We can't write a method that takes a copy of an array list of integers in Java. We write a method that takes a reference to an array list. So we still have that assignment just like this line here, except that assignment is split across parameters and arguments. So we have array list of integer Rin equals R1. It's the same thing we have on this line, but it's created in a separate stack frame. So Rin has that same reference. We have three variables on the stack now, all referring to the same array list. And then when we go through our array list in the method, we got our stack frame, our name of it, our return arrow, and our parameter. We're going to create a local variable out, go through this list. I'm not going to go through the whole thing, but every time we update the variables, we're going to get the values from that same array list by going to OX200 and navigating through the indices 0, 1, 2, 3. X actually does get to 4, but never gets that index out of bounds error at 4. So we do less than 4 for our, less than 4 for our variable. Size is 4. There's 4 elements. 4 elements. Update our out, and then return out. So that method didn't get a copy of that array list. It got a reference to that same array list. It went to the same spot in memory that the other two variables refer to. Then we're going to print total, and that's the end of our program. Do we need to put the arrow? Yeah, I didn't mention the arrows. The reference arrows are optional, and I'll only use the arrows for the first few memory diagrams that have the heap. They use the heap. But the return arrows are not optional. You have to do your return arrows because those hold information. But the references, like OX200 and OX200, if those match, it's a reference to that object. Yes? Mm-hmm.
Do we consider that a pointer?
Not quite. They behave just like pointers in C and C++. Java just doesn't call them pointers. But if you think of them as pointers, yeah, they behave exactly like that. ArrayList does override the toString method. That's why we get this behavior printed. But if you write your own class, or if you use the vanilla array, like if we try to print out args, we're going to get that messed up print line. Bless you. But since it's an array list does have an overridden toString. For those of you who don't know what I'm talking about, I'm just answering a question here, and you don't have to worry about that one quite yet. Not until we get to inheritance are we going to talk about that. Yes, so I don't do it in this example quite yet. I just want to introduce the heap in this example. But if we do change something on the heap through any of these variables, it will change it for all of the variables. And that's when it really becomes important to understand these references. So if this method modified RIN, even after the method call, R1 and R2 would effectively be modified because they refer to the same object. Yes?
So does the actual array list on the heap not really have a name? There's just
Right.
names that sort of affixed to it?
Correct. Yep. So this, yeah. So in programming, looking at this code, we like to call this array list R1 because that was the first name that it had. But that's kind of meaningless. If I were to call it anything, and in lectures, this is what I'll call it, is the array list at OX200. That's its more meaningful name, which isn't really a name. All right, let's get the hash map. We got 20 minutes. We might not even get to do many examples in IntelliJ. All right, so let's go over hash map. This is our typical key value store. So any language you're coming from, Python, this is our dictionary. JavaScript, this is our object. C++, this is our, I blanked on it last time too. I think it's just map in C++. But it's our typical key value store. Instead of storing values at indices starting from 0 with a defined order, we have values stored at keys, where the keys can be any values that we want, and the order does not matter anymore. We also can't have duplicate keys. This is something we teach you in 1.15. Hopefully they got that in your head in 1.15. I don't have to talk about it too much. But we can't have duplicate keys. One key maps to one value. Can't have two keys with the same value mapping to, oh, I said that weird. We can't have the same key mapping to two different values. Can't have it. Can't happen. Same thing, we have to import this, just like array list. Not much more to say about that. Same exact structure as array list. The constructor, I don't have anything to say about that. Same exact structure as array list. Our first difference here, though, is a hash map takes two type parameters. So instead of just specifying the type of the values like we did with an array list, now we specify the values of the keys and the values, and they can be different types. So when I see this hash map, the way I would read this is a variable of type hash map of string to integer, or from string to integer, I guess is how I put it here. But that's how it'll be in the homework. Create a hash map that maps strings to integers. I cited a few different ways there, but type to type, that's going to be in there somewhere. The first type is going to be the type of the keys. Second type is the type of the values. And they're comma separated for what it's worth, just like any other lists. And I forgot to mention it on array list. I said I'd mention it. These angle brackets, we can put the types here. This is another type parameter list. And we can type string comma integer right here. That's completely accurate. It's what's supposed to be there. But this is one of the kind of few things where Java lets us use some shorthand. It says, look, you're creating a hash map and assigning it to a variable of type hash map of string to integer. I know this is going to be a hash map of string to integer. You don't have to tell me twice. So we actually can optionally leave that type parameter list empty, and then Java will infer what those types are based on the type of the variable that we're storing it in. But if you type string comma integer, that's more explicit. It is correct. And IntelliJ will say, hey, you didn't have to type that. Why'd you even type that? And it'll recommend that you remove it. So one shorthand that Java isn't big on shorthand, but that's one shorthand that Java likes us doing. When we add key value pairs, we use the put method. So we're going to put a key value pair into a hash map. And to get a value at a specific key, we're going to use the get method, just like we did with array lists. Except instead of getting at an index, we're getting at a key. Give me the value stored or at this key, or give me the value that this key maps to. And then our first instance of an enhanced for loop, which Java calls them. I call these for each loops because that's what they're called in other languages. But in Java lingo, it's enhanced for loop because they got to be different, I guess. I don't know. Or maybe they named it first and everybody else is different. I don't know. But if you see enhanced for loop, that's what they mean. You've seen Python, most of you anyway, if you did 115 here. So this is just the type of loop that you're used to. It's the only kind of loop Python has. That's not true. Python has a while loop too, doesn't it? But it doesn't have the standard for loop. So these loops are going to be type and a variable. So we're declaring a variable, colon, and then some data structure, whatever data structure you want to iterate over. Is going to iterate over all the values of that data structure. I don't think I have to talk about it more than that since you've seen it in 115. For those of you who haven't, I don't think it's too outrageous. It's simpler than a standard for loop, in my opinion. But create a variable, and then this loop will go through all of the values in this data structure and put each value one at a time into this variable. And then looping over our hash maps, we have three choices for looping over these, or I guess two choices that I have on screen. I didn't do the entry set on here. I think it's a little more confusing. For what it's worth, I don't even use it. I just think it's more to remember, remembering the syntax. But either the keys or the values, and I think even the methods are exactly the way they are in Python, so nothing too crazy here, nothing too new if you remember Python. If not, key set is going to give you a data structure with all of the keys only, and values is going to give you a data structure with all of the values only of the hash map. For my money, this is the way I like to do it. I'm going to iterate over the key set, unless I have a very specific use case. This is my standard way. I'm going to iterate over the key set, get all the keys one at a time. The keys in this hash map are strings, so my variable type has to be string. And then I'm going to access the value at that key to get the value. And now I have both key and value. I have full information as I'm iterating through my hash map. So iterate over the keys, get the values. If you want to look up the documentation for, oh my goodness, I just said it and I'm blanking on it, but the where you iterate over the keys and values at the same time, entry set. If you want to look up the documentation for entry set and do it that way, iterate over both, knock yourself out. I don't memorize the syntax, and I don't know, I never really felt like it, to be honest. So we iterate over the keys or the values, or iterate over the keys and grab the values. Let's see it in action. So this is going to be the same idea. I don't have too much more to say in the memory diagram. It's going to be the same idea as the array list. Hash map is going to go on the heap. And what's stored on the stack is only a reference to that object on the heap. Here, when I made this slide, I made up the number 519. That's just what I was feeling when I made up this slide. There's no meaning to that number. There is when you actually run your program. There will actually be a physical address on your memory card, on your RAM cards, where that value is, where that hash map is actually stored, and that number will exist. It will be meaningful. But when we're doing a memory diagram, we don't have a physical computer, physical memory. We're going to be the operating system and just choose where in this fictitious memory to put that hash map. So I made up 519. I just said, you know what, I think this is what the OS would have gave it, where it would have stored this thing. So OX519, that's what's stored in our variable. When we add our values, instead of like our array list, we had index and then the value. Now we're going to have key and value. What else would we do? That makes sense, right? We're going to put key and value to keep track of all the information stored in this array list. We're going to print out a few things. For what it's worth, and I have to be careful when writing quizzes to make sure this doesn't matter. For what it's worth, the order doesn't matter in our array lists. So when we, or array lists, my goodness. Order doesn't matter in our hash maps. So when we print things out or when we iterate over our hash maps, we might not get them in the order that we expect. In fact, when I run this code, I get the values, key value pairs, in the opposite order in which I inserted them into this hash map. For your memory diagrams, you can just pick whatever order you want. I'm not going to have you try to predict which order they would actually be iterated over. It is deterministic. We could actually determine that, but oh my goodness, it'd be a disaster. I wouldn't want you to have to do that. It'd be a lot of memorization, and it wouldn't be worth it. So whatever order you choose, and then I have to be careful when I make the quizzes to make sure that the order doesn't matter. So whatever order you iterate over those things, which will usually just be the order in which you inserted them in, that's what I'm going to do here. That'll be just as good as any other output. So when you actually run the code or when you do the memory diagram, whatever order, it's going to be correct anyway. Maybe the order in which things are printed out will be a little different, is all. And this is the syntax for how Java will print out a hash map, which I don't expect you to remember. I don't think I'll ever put that on a quiz where I just flat out print a hash map anyway. But for what it's worth, that's the syntax too. I already said all that. Keep up, slides. So now I'm iterating over the key set, and I'm going to print out each key. And now I'm going to just choose whatever order I want. This output, I did cut and paste from when I ran this code, just so I can make that point of the order not mattering. When I'm going through these for loops, I'm going to iterate over them in whatever order I choose. I'm going to iterate over them in the order in which I inserted these key value pairs for these. Just for my memory diagram. Doesn't matter if you do them in a different order. If you want to choose whatever order you want, go for it. I assume most of you will just go in the order of the key value pairs, the order in which they were inserted. All right, so we're going to loop. For a for each loop, same thing as a regular for loop. The iteration variable is going to be part of the loop code block. So key, that variable, is inside the code block for this loop. It's going to get one of the two values. I chose Alan first, and then that value is updated, printed to the screen, then updated. We're going to cross it out, write the new value, print out digs, and then that is the end of the loop. These loops are going to iterate over all of the keys. There's only two keys. We get to, after the second key, that's the end of the loop. So key is no longer on the stack, which means we can reuse that variable. Values, same thing, but we're going to iterate over only the values. And then we can reuse key, since it's not on the stack anymore, it doesn't exist anymore. We can reuse value, since it's not on the stack anymore, it's removed from memory. We can actually reuse both of these variable names in our next loop. So we don't have to say like key 1 and key 2, or key 1, value 1, key 2, value 2. We don't have to do any of that stuff. We can reuse these because they're in different code blocks. So we can reuse both names and print out both of them. Okay, any questions on array lists or hash maps? Are any of these data structures immutable? Not the ones we're using, not array list or hash map. This course used to be in Scala where they were all immutable, and immutability was a whole week's topic, and I don't know if anybody got real benefit out of it. Immutability is a really important topic, but not yet. Like it doesn't help you at this point in your careers. But in a few years, you'll need to understand immutability. It was too early to teach it in 116. Unless somebody asks, I'd be happy to. No one? Yeah. It is a fun topic, but it's just a lot of details for not much benefit. If you understand immutability, there's not much, what I mean by all that, there's not much more that you can do. You can just do the things you could already do more efficiently. But at this point, we still want to be able to do more things and do them in better ways and organize our code. We're not ready to talk about efficiency. We're not ready to care about efficiency, I should say. We still want to make programs that do cool things. And then we'll worry about making them do those things faster. Oh, shit, I have IntelliJ closed. All right. This is the first time I'm opening IntelliJ and lecturing it. It's too late. Too late for having the very first time. All right, so I'm going to open the examples repo. You've all had lab so far. You should have this cloned on your machine. You should have IntelliJ up and running. If you don't, I don't know. Well, you just should, because if you skip lab, that means you already had it set up. I guess if you were sick and had to miss lab. So let's go to our array list example. And first of all, we can run this code and verify that it does do exactly what we expect it to do. It's programming, so we're going to hope it does what we expect it to do. Oh my goodness. This is actually perfect. You already went through this in lab, but I have the wrong Java version. I intentionally broke this because the TAs were asking and I was doing some testing. I have in the POM Java 20 as when you clone the repo, I have it set up to Java 20. If you get this error, you can change this to 19 and run and use Java 19, or you can leave it at 20. Go to your project structure and change your JDK to, oh my goodness, I have so many of them set up. You know what, I'm just going to change it to 19. And then download Java 20. I didn't realize that was going to cause so many issues in lab this week, but quite a few of you were getting the incompatible Java versions. Either one of them will work for the course. Oh my. SDK 19. Live demos are always scary. Anything can go wrong. See, and then it just does what we want it to do. Perfect. I updated my pom.xml without reloading Maven, for those of you wondering what happened there. If you're seeing that same issue, I have time after class. I can help you get those things sorted out. But it prints out what we expect it to print out. But what I want to show, this is going to be the very first time I'll show what's called the debugger. I'll give a bunch of examples like this. But if I click next to the line number, set what's called a breakpoint, and then run my program in debug mode, what this does is allows me to step through my code one line at a time, and it will show me what's happening in the heap and stack when the program executes. It'll show you everything that we put on our memory diagrams. So if we get to, let me get to a method call here. Oops. I can see that I have two stack frames, the main stack frame and the stack frame for the sum method call. And I can see all the variables in each stack frame. And whenever I see a variable, this array list at 730, that's like our OX 730 in memory diagrams, we know that this